So here I'm just going to talk about what we call the standardized normal distribution. As we've seen, the normal distribution has two parameters that can be changed, the mean and the standard deviation. And if we change it so that the mean is 0 and the standard deviation is 1, that's called the standardized normal distribution, which is normally denoted by a capital letter Z. So we normally use capital X's to denote other normal distributions with different means and different standard deviations. And once we change it so that the mean is 0 and standard deviation is 1, we use a Z, a capital Z instead. And this is going to be useful in a certain set of questions that we're likely to meet. But essentially there's a formula that I want to just quickly show now that links the values from an X distribution to the values from a Z distribution. If we go back to what we had before, we had a mean of 5 and a standard deviation of 2. Let's put in a particular area here. Okay, so what you can see is that on this distribution with a mean of 5 and a standard deviation of 1, the probability of being less than 6, of X being less than 6, is 0.69. Now, for my Z distribution, if I now bring up the Z distribution, there is an equivalent value that I would be able to find. In this case, it's 0.5, that would give me the exact same area of 0.69. And the formula I'm going to try and attain is how would I figure out what that value is? What would I need to do to this value of 6 to get that equivalent value of 0.5 that would lead to the same area? So if we just go back to the one that we've got, let's just get rid of these areas for a second. Okay, what I'm going to try and do is just figure out how do I go from this distribution to this one over here? Well, the first thing I need to do is I need to change the mean from being 5 to having a mean of 0. So that means subtracting 5 from each of the X values. So if I subtract 5, then I'll end up moving to over here. And what you can see is that would have changed. If we just go back to what I had before, I was looking at a value of X as being 6. So by subtracting 5 from the mean, that value of 6 here will change to being a value of 1. Hopefully you can see that is basically the same value having been translated 5 to the left. And then what's going to happen if I want to get that area but have it equated to an area that's on my Z distribution as well? Well, if you look at what happens if I change the standard deviation to being 1, that point has essentially been halved. So that leads us to a formula that the Z value can be obtained by taking the X value, subtracting the mean, and then dividing by the standard deviation. So just to show this in action, let's take this as our first example, this one here on the left-hand side. If X is distributed normally with a mean of 7 and a standard deviation of 3, and we wanted to work out the probability that X is less than 10, we can see that the way that I've set this up, that probability would be 0.84. If we apply this formula, we would say the X value is 10, so that would go there, 10, take away the mean, which is 7, so 10 take away 7 is 3, divided by the standard deviation, which is also 3, so 3 divided by 3 would be 1. If I bring this up now, we can see that that is the value that would give me the exact same probability if I work out the area beneath that value of 1. We just take a second example. Let's say that X is distributed normally with a mean now of 5 and a standard deviation of 2. If I use my formula, I'll be doing the X value, which is 6, take away the mean, which is 5, that gives me an answer of 1. 1 divided by 2 is a half. Sorry, I need to just change my upper limit here to being 6. So we said that this formula then will make this into a half, and if we change that, we can see that that proves to be the case when when the Z value is equal to a half. I get a probability beneath that value of 0.69, just as I did for the probability that X is less than 6 over here.